HVAC ductwork design. 7 principles to improve efficiency. In the world of heating, ventilation, and air conditioning, ductwork design is a critical aspect that often goes unnoticed until problems arise. Yet, for HVAC professional, commercial building managers, and homeowners alike, understanding the principles behind efficient ductwork design can make all the difference in energy savings and air quality. This blog aims to demystify the intricacies of ductwork design, providing actionable insights and practical tips to enhance system efficiency and performance. Understanding the importance of efficient ductwork. Efficient ductwork is the backbone of any high-performing HVAC system. It ensures smooth operation by facilitating the free flow of air, which in turn reduces energy consumption. A well-designed duct system minimizes leaks and prevents uneven air distribution, which are common culprits of inefficiencies. For homeowners and building managers, poor ductwork design can translate to higher energy bills and uncomfortable living or working environments. By focusing on efficiency, you not only create a more cost-effective system but also enhance the overall comfort of indoor spaces. Number 1. Fluidity. Fluidity in ductwork design refers to the smooth and unrestricted flow of air through the system. Achieving this requires careful planning and consideration of the duct layout. Smooth, round ducts are ideal as they offer less resistance and maintain consistent air pressure, reducing the strain on the HVAC unit. During installation, it's crucial to address any leaks or loose connections that could disrupt fluidity. Ensuring airtight seals helps maintain efficient airflow and lowers energy costs over time. Number 2. Materials and shape. The choice of materials and the shape of the ducts are fundamental in determining the efficiency of the system. Common materials include galvanized steel, aluminum, and flexible ducts. Galvanized steel is known for its durability, while aluminum offers a lighter alternative with similar longevity. When it comes to shape, round ducts are generally more efficient than rectangular ones. They provide less resistance to airflow, leading to improved energy efficiency. Investing in high-quality materials can result in long-term savings, even if the initial costs are higher. Number 3. Ductwork insulation. Correct insulation is essential for enhancing the thermal performance of ducts. According to ASHRAE 90.1-2019 guidelines, insulation helps prevent condensation and dripping by maintaining the desired temperature of the air being transported. Uninsulated ducts can lead to energy wastage as additional heating or cooling would be required to achieve the designed supply air temperature. Insulating ducts eliminate the formation of condensate, preventing potential water damage and microbial growth within the building. This is particularly important for maintaining the integrity of the HVAC system and ensuring indoor air quality. Number 4. Zoning. Zoning involves dividing a building into smaller areas with independent temperature controls. This allows for greater comfort and energy efficiency by preventing overconditioning in unoccupied zones. Proper zoning influences duct routing and often requires multiple ducts to serve each zone. While the initial cost of implementing zoning may be higher, the benefits in terms of comfort and energy savings are significant. It also reduces equipment wear and prolongs the lifespan of HVAC component, making it a worthwhile investment for both residential and commercial buildings. Number 5. Duct sizing. Accurate duct sizing is crucial for optimal system performance. The goal is to design a system that operates at the lowest possible static pressure, reducing both initial and operating costs. The constant friction loss method is widely used for sizing ducts, as it provides a straightforward way to manage airflow velocities. Undersized ducts can restrict airflow, leading to inefficiencies, while oversized ducts can increase costs and energy wastage. By keeping air velocity within recommended limits, you can ensure a quiet and effective system that meets the specific needs of the building. Typical design friction rates are 0.1 inches of WC per 100 feet. To avoid disturbing noise levels, maximum velocities within experienced limits. Comfort systems. Air velocity 800 to 1400 fpm. Industrial system. Air velocity 1500 to 2400 fpm. High-speed systems. Air velocity 2000 to 3600 fpm. Number 6. Air duct sealing and leak testing. Sealing ducts effectively is vital for preventing air leaks and ensuring efficient airflow throughout the system. Leak testing identifies areas of potential air loss, allowing for targeted improvements. Correct sealing reduces energy waste and lowers utility bills, contributing to overall system efficiency. The choice of sealants, whether mastic, tape, or gasketing, should be based on joint configuration and surface conditions. Adhering to ASHRAE 90.1-2019 requirements can further enhance the effectiveness of duct sealing, ensuring a well-functioning HVAC system. Number 7. Aspect ratio. The aspect ratio of a duct, defined as the ratio of its width, long side, to its depth, short side, plays a crucial role in duct design. A higher aspect ratio leads to an increase in both the installation and operational costs of the system. Rectangular ducts with an aspect ratio closer to 1 have lower frictional resistance and require less sheet metal. However, as the aspect ratio increases from 1 to 1 to 1 to 4, the surface area and insulation requirements rise by 25%. Keeping a low aspect ratio offers several advantages, including reduced friction loss, lighter metal weight, and lower insulation and installation costs. Conclusion. Ductwork is important for ensuring temperature consistency and air quality for the entire structure, which contributes to well-being and occupant comfort. Designing an effective and optimized HVAC ductwork system is complex. It requires consideration of various factors, including the building layout, occupancy patterns, air distribution patterns, and more. By following these top 7 principles, you can create a system that not only meets the heating and cooling needs of a building but also operates efficiently and cost-effectively. Collaborating with HVAC engineers from Design Scorpion team throughout the design process can help mitigate common issues such as leaks and uneven air distribution, resulting in a well-functioning system that meets both performance and budgetary goals. By prioritizing ductwork efficiency, you can enhance indoor air quality, reduce energy consumption, and contribute to a more sustainable environment. Thank you for watching this video. We look forward to seeing you in the next one. Please subscribe and leave a comment. Thank you.